Hello, everyone. So, I'm Davin Miller, and my project is focused on comparing the players and positions in the National Football League. And I do so using metrics such as their performances, contract information, and player descriptions. I scraped my data from two websites and combined them into this one large Excel file that we can see here. So one of the websites is called stathead.com, and then one is called overthecap.com. Stathead is a widely renowned sports statistics hub, and I scrape data pertaining to each player's seasonal performance. And then Over the Cap is a website run by a single statistician, and that contains the contract information of every player who's played in the NFL from 2000 to 2020. So initially, I'd wanted to use data from the entire history of the NFL, but this data was not really made available by the NFL before 2000. And so instead of trying to compare different ages of the NFL, I went in a different direction and decided to compare positions and players directly in this era after the year 2000. So, for example, some of the questions I wanted to answer was like, how do the distributions of pay or performance differ between important positions such as the quarterback and then other less important or like renowned positions such as like a center or a safety? How do some of the best players at their position compare to each other? And for example, did one of them offer a cheaper performance per cost metric than the other over their whole career? For example, is like Tom Brady, was he better per cost than someone like Peyton Manning or something like that? Obviously, these two are both amazing quarterbacks, but we can do more nuanced comparisons across the entire league like that. And so I combined the data sets using Python and SQL such that for each player, we have their seasonal performances as well as how much they were getting paid during each season. This made these types of comparisons possible. So to open up the program here, you want to navigate to the directory where the main file is located along with the Excel file. Then you can open up a terminal. And so this is programmed in Bokeh and Python. So to run a Bokeh server, it's the Bokeh serve command. So we'll type that in. And so this will open up kind of a local host place where once it's finished loading, we can now see it's kind of like an interactive visualization. So we can compare positions, compare players, and compare all positions. So first, we're going to go exploring into the positions one. We can see that we can compare using scatter plots, densities, or histograms. So let's just say, for example, I'm comparing between quarterbacks and centers. We can actually select independent teams here, but I'm just going to be comparing all of them for now. So AV is approximate value. This is one of the most important metrics out of all of these variables. AV is how they measure performance per season for each player. And then we have the y-axis could be another variable to compare. So we can look at, let's say, APY, inflated APY, which would be how much the player gets paid per year in terms of today's money. And then also the size of the variable. So we basically have three variables we can choose from here. Size is another variable that will, in terms of the scatter plot, will be available. So we can do contract years and then update graph. So you can see that we get a scatter plot with three different dimensions. The x-axis, it would be the AV, how well the player performed that particular year. So we can see that the higher values are like Aaron Rodgers here, who's a really good quarterback, or Patrick Mahomes. It's another really good quarterback, so they have high values on this list. The x or the y-axis is inflated APY, so how much they're getting paid. So in this year, Patrick Mahomes is actually getting paid a lot more than Aaron Rodgers. And then the size variable we set to contract year. So we can see that Patrick Mahomes has a huge contract, gets paid a lot of money, and he performs quite well for his team in the year 2020. We can actually look at how that compares to centers, and you can see that the maximum center really gets paid a lot less than quarterbacks, and they tend to, I guess, not be as influential on the game in terms of like they're not having as high of an AV impact score. So that's just one of the things that we can find with this. So let's move on to the density graph here. And the density graph was just comparing one variable between certain positions and or teams. So if we start off with AV, you'll see that we can see like a more bimodal distribution. And this is density graphs are analyzing the population distributions, which we learned earlier this year. But essentially you see that in terms of the performance value, we see they're bimodally distribution because you have your set of backup players. So these two categories would be all the backup players that don't really contribute much during the season. And then you kind of have your starters over here, which play much more games and therefore contribute more. We can also look at like inflated APY, all these different types of variables to kind of see how does this variable distribute across the population. And then next we can look at histogram, which is similar to the density, except we're looking at a histogram instead. We can align bins or not align bins. Align bins will make them the same. We can look at different variables, just see how the populations just change between all of these different types of um, positions in the league. So it's a really interesting way to compare positions. So this is the first part of the project. The second part is comparing players. So this is actually, instead of comparing players, I'm actually going to talk about comparing all positions first, because this is a much smaller section. So what we can do is select a variable, say AV, and then this will actually plot all of the densities for every single position over the whole league. We can see the population distributions among this variable for all these different positions. So it's kind of a really unique way to kind of see how these compare. And so you see some interesting positions like long snapper will get paid much more evenly than some of these other ones, where you have huge peaks here and then some select players getting paid a ton more for really good performances. What's interesting, my favorite part of this graph is when you look at the radial. So we select the top 10, top 100 players of each position and look at kind of a radial graph, which contains, let's do AV first, how much each position is contributing to the whole. And so we can see that quarterback positions contribute the most, and then you can look at each individual quarterback since 2020. So you have like Tom Brady, Aaron Rodgers, Peyton Manning contributing a lot, and even other quarterbacks, Eli Manning, Joe Flacco, some of these lesser known quarterbacks or famous quarterbacks producing a lot as well. And you can compare that for like every position, which I think is really cool. And you can do this for all these different variables and then kind of just explore as you go. Lastly, I want to look at the compare players. And so this is a way to just compare different player stats over their entire career. So the one I have on default is Tom Brady versus Peyton Manning. So we can start off with this scatter plot. We can look at line plots, bars, and then a radial plot of each of their seasons. So these are actually very close. And actually, this is not updated for when Tom Brady, because Tom Brady still plays this year. But Tom Brady scored around 269 total points in terms of his performance metric. Peyton Manning scored 272. So technically, Peyton Manning was slightly more valuable in total. And you can see all their individual seasons here. But if you look at the denominator, there's inflated APY. And look at radial here, we can actually see that Tom Brady was a lot more valuable in terms of performance per cost. And so lastly, after showing some of the examples of all the visualizations you can create using my interactive software, I just wanted to kind of talk about some of the outcomes of my graphs and what I've kind of found throughout exploring. And so some of these insights I found were the quarterbacks comprise the largest section of AV, and this is expected as the quarterback is the most important position in the NFL. However, we see that even relatively mediocre quarterbacks such as Andy Dalton and Alex Smith, who aren't as renowned as some of the other ones, were able to make some of the top 10 or top 100 list in the NFL with respect to AV. And so, given that this is over 20 years of data, this is actually quite surprising that this happened. It appears that the chance of making a large impact in the NFL is very slim. You can see that with the density graphs we saw earlier, how much percentage of the population belongs in this category right here. So this indicates that most players have little to no impact on their team performance, and this could be caused by how injury prone the sport is. Positions where injuries are less common, such as quarterback, long snapper, and punter, have a bimodal distribution for AV, where the left bell curve represents the backup players and the right represents the starters. So you can see punter here and kicker, they have a much different distribution for approximate value versus some of the other more injury prone positions. Another cool thing that I talked about earlier is we can compare the best players in this time span. So for example, I compared LaDainian Tomlinson with Adrian Peterson, they're both considered to be top 5 NFL running backs in history. And LaDainian Tomlinson was found to have, a profound career, and he outscores, if we select none here, he outscores Adrian Peterson in terms of approximate value. But if you look at inflated APY and adjust for how much they get paid, Adrian Peterson actually provides more bang for your buck type of thing. So it seems like there's a lot of different things you could argue between these two different running backs, and we saw the same with Peyton Manning and Tom Brady. So it's just really interesting to consider, like, do you value more performance up front by paying more money, or do you value paying players and getting more bang for your buck, essentially? You can experiment around with yourself. You can compare positions, compare players, compare all positions. There's a lot of different graphs you can explore here. And I've just kind of touched the surface of really what's possible with this program. I think what's really cool about my project is the interactivity and how much possibilities there are with the program. So thanks for watching.